This is my talk, Lessons Learned from Building a Video Game in React. My name's Drew Conley. I'm here from St. Louis, Missouri. I'm a web developer at a company called Caleres. Caleres' big thing is famous footwear, the shoe stores. Maybe you've seen our shoe stores around. I'm a web developer there, and I'm here today to talk to you about video games. So to kick us off, I've got 3 questions to get us started. Just raise your hands to answer the questions. I can see the hands now, yes. Okay, question 1. How many people here today play video games for fun? That's awesome. That's like almost a lot of hands. Yep. Okay, question number 2. How many people, as you're playing a video game, start to reverse engineer parts of it in your mind, and you wonder kind of how it was made? Excellent. Still a lot of hands. All right, and third question. How many people today have considered making a video game of your very own? Still a lot of hands. This is great. I have a story to tell you about that very topic. It starts with my favorite place in the world, Chipotle, the Mexican restaurant. So like I mentioned, I work at Caleres, and Caleres is located in this really beautiful part of St. Louis, Missouri called Clayton, where there's like these big office buildings and green parks and brick roads and old shops. It's like really inspiring to be there. It feels like you're walking around a movie set, kind of. So one day we were doing our usual thing, which is walk into Chipotle for lunch, and my friend Henry, who's here today in the audience, stops and says, "Guys, we need to make a video game about this in the browser, like where you're a div element and Chipotle's a div element, and you walk to Chipotle, and that's the game." And we were like, yeah, that sounds cool, but we didn't stop there. We kept piling more ideas onto this fairly simple game idea. And we ended up with this big RPG game where you're a developer and you face off against other developers in hack battles. And you gain experience points for winning the hack battles, and there's like boss fights and a whole storyline. It was like this whole big, real RPG game with a lot of features, kind of like the kind that we grew up playing, that we fell in love with when we were kids. And we were really excited to get started on this, but I had a ton of hesitations right off the bat. For one, this seemed like a huge project with lots of complicated state, like way more than your average web UI, lots of things going on here. Didn't even know how to get started, it was so big. Secondly, usually when I hear about people making games in the browser, Canvas comes up, and I'm a noob at Canvas. It seems really cool, but I didn't know how to approach it at the time. Could this be done without Canvas? And finally, this is supposed to be a game that you play for 30, 40, 50 minutes at a time. What happens if you're playing the game for a long time, the browser session gets really long, and your application state gets in this like perfect storm situation, and you get a random runtime error or something like that, and then all the progress you built over the last 30, 40, 50 minutes is just crashing and burning? That would be really bad. So we need a way to work on this and track down those kinds of weird situations. And all these together at first made me feel like this is not possible for the web right now. It's just not. And the good news is that I was wrong. This is possible on the web. And I'm happy to be here today with a demo of a game we've been working on called The Danger Crew. It's an RPG you play in your browser. Are you ready to see the demo? Yeah, awesome. So I'm going to switch to Chrome. Nice. All right, so here's the title screen of our game. I believe I have sound. I'm going to press enter to get started. Awesome. We have this really great music that Henry made. So here I am in the streets of Clayton, Missouri. I'm controlling the character in the middle of the screen. His name is Jacob. I'm using the arrow keys to walk him around, but WASD also work for the hardcore PC gamers out there. This game also has touch support, so if I'm on a mobile device, I could like use my finger and grab and move him around that way. So if I walk to the right, I'll see some people hanging out in the city. If I walk to the left, I see some shops that we can hang out and go in. And with the spacebar, I can talk to people. So I'll talk to this guy. He says, have you been to South North before? That's the coffee shop straight ahead. Developers are always hanging out there. So he says we should check out the coffee shop. Let's go ahead and do that. All right. So we walked in the coffee shop. Here it is. I can like interact with things in here. You know, almond milk always costs extra. Sorry. And so, like the guy outside said, developers always hang out here. If we walk around and hang out long enough, maybe someone will challenge us to a hack battle. So let's see. Oh, here's one. Punky says, press enter to accept. He's on level 2. We're still level 1. I think we can beat him, though. So I'll press enter to accept. And now we're in a turn-based battle. Punky challenges Jacob to a hack battle. Now, the premise of a hack battle is a little silly, but you're a developer, your opponent's a developer. You fling terminal commands back and forth at each other, trying to drain your opponent's laptop battery life. So like, this could be a real thing one day. So we have two attacks to choose from, slice and curl. Slice is an offensive move. We'll go ahead and use that first. Jacob used slice. Nice. That was a pretty good hit. That did more than half. All right, now Punky's using a move called curl. What that's going to do is go out and download some of the items that we have in our bag and steal them away from us. So we had a mini battery pack in our bag, but he just stole it away from us. Jerk. OK, I think one more slice can finish him off. And it did, yes. We've won the hack battle. So Punky has run out of battery life. Jacob is the winner. Now, because we won, we receive experience points. This little pop-up is going to tell us that we've gained enough experience to go from level 1 to level 2. If I pause the game with the escape key, I can access our pause menu. So here I can press enter to level up, and we get a new skill point to invest in our character. So what do you guys think? Health, attack, defense, speed, or efficiency? I heard efficiency loudest. Is that fair? OK, we'll use that. Nice, good choice. I like that one. So we'll press enter to submit our level up. Nice. Now we're on level 2. And because we've leveled up, it looks like we have a new attack. See the attacks tab has the new badge on it. So here, it looks like the for each attack is now available for us to use. So I can press enter, and now in our next hack battle, for each would be available. As you can see, there's a lot more attacks to unlock here. And that is a demo of our game, The Danger Crew, an RPG that you play in the browser. Thank you. I'm going to go back to my slides. There we go. OK. So there's only 3 people that worked on this. I was the front-end developer on it. My friend Henry, who I mentioned before, remember from Chipotle, he did all the music, while my friend David, who's also here today, did all the graphics of the characters and the maps. It was just like 3 front-end developers taking a stab at something new. But it wasn't that new, because everything I've shown you today is just a React app. I used React for the view layer, Redux for state management, and just a lot of CSS tricks to make it feel kind of like a video game. Before I started this project, I thought that game development and web development were 2 completely different worlds. And to get into game development, I'd have to kind of start over and like learn a whole new platform or a whole new language or whatever. And it turns out that you absolutely can make really rich, deep gaming experiences in the web using the same technology that we use today to build web apps. So my hope here is that if you've ever been curious about making a game, if you've ever thought about it, that the things I'll show you today will show you that the things you know as a web developer are also useful for making video games, and you can get started right now. So to do that, this talks about you making games. To do that, I'm going to rip open parts of my game and just show you how I handled a few areas in React. We're going to talk about walking around an overworld. We'll talk about turn-based battles. And then I'll show you this concept that we've used to keep the project really maintainable and easy to work on. So let's dive right in. The first area I want to show you is walking around an overworld. We were inspired by the early Zelda and Pokemon games where you're a character walking up, down, left, or right on a 2-dimensional plane. And you're exploring this big world. And the world is made up of a smaller unit called a map. And a map is just a data structure that's loaded into application state. It kind of looks like this, where we have a background image. That's the actual asset that we're using to walk around on. We have a collection of walls and a collection of people. And I like to just start with an empty canvas here and add one element at a time. We're going to slowly build up this walking engine. So we start with this like battleship-style grid with an x-axis and a y-axis. And we can place our first React component called a person that takes in an x prop and a y prop. And those values just correspond to both the x and y axis. If we multiply the values there by the size of a grid cell, we can get back CSS top and left values to absolutely position the character in the correct grid cell. Now, the person here is hooked up to the arrow keys. So if you press, say, the down key, an action will get sent up to application state. A new state will be created with an updated value for the person's y. It'll increment by 1, right? The person will receive his new y value, and React will do its thing and re-render, and the person will now be here in his next spot. So right off the bat, this guy is hooked up to the arrow keys, and we can move to any spot that we want. But the thing about being in a real world is that you can't just move anywhere that you want, right? We have walls and things around us that stop us from going places. So if you remember, a map data structure had a collection of walls in it, and that's just a list of spots on the grid here that are taken and that you can't move there. So now, when the player presses the arrow key, we will ask application state, hey, is there anything where, like in my destination, where I want to go? If the answer is yes, there's something there, then the request to move is denied and nothing happens. But if the answer is no, then we're free to just go ahead and move like we did before. And now we can move anywhere except the spaces that are marked. And this is good, except right now, when the person component receives a new X or Y prop, the graphic will just kind of teleport to its next location because it's just snapping to this grid. We want it to feel a little more alive, like the character is walking to his destination. So if we zoom in on a character himself, he's actually just one SVG file that has 16 different frames arranged like a sprite sheet. This is like an old school CSS technique. And using the magic of CSS background size and background position, we can target just one frame to show at a time. Now, instead of just updating the X or Y prop willy-nilly, when we're going to move somewhere, we'll kick off a loop with request animation frame. Sarah Drasner was teaching us about that yesterday, where while this loop is running, the character will gradually transition into his new spot. While he's moving, we'll give a keyframe animation to him. This one's called walk down, and it uses the steps easing function in CSS. If you're not familiar with steps, it's like an alternate to ease in or ease out. It lets you leapfrog across values. So if we apply this, we get kind of a stop frame animation out of this graphic. Now, if you put that all together, it looks like this, where we have a character, he's walking around. When he's moving to his next spot, he has that animation, and he can't collide with walls. This is a really good start, but it's very lonely. The thing about RPG games is that there's a world you're in, and the world has other people in it, and you like help the other people with their problems. So the good news is that everything we've put into Jacob, the player component, is also reusable for other people. We just need to render more instances of the person component. And we'll accept one more prop, and that's the skin, like what the character looks like. Now, the other thing, these NPCs, non-playable characters, don't care about the arrow keys because they're not player controlled. Instead, they have internal state that tells them where they walk or what they say when you talk to them. So still a lot of reuse going on. There's one last thing that glues this whole walking engine together to make it feel like a video game, and that's a game viewport. I want you to keep your eye on this green outline in the middle of the screen. That is our game viewport, and it's not moving, but this pinkish red plane inside it is moving relative to the top left corner, and the people are positioned relative to that. If we just throw overflow hidden on that, we get this kind of Game Boy effect where we can't see anything outside the green lines. And then because we're dealing with SVG, we just scale it all the way up to however much screen real estate we have, and then everything, we don't lose any quality because it's vector. You put that all together with the graphics of the game, it looks like this. We have the character walking around, people on the map, still can't collide with walls, you can talk to people. It's a walking engine. I think the big takeaway here is that while you can do a lot with just CSS and a handful of DOM elements. At the time when we started this project, I wasn't familiar with Canvas. I've since played around with it, and I really like it. But you don't have to use it. Like, some games just don't require it. And if you don't know Canvas, don't let it be a barrier to entry to getting started and making games. You can absolutely use DOM elements. So that's a little bit about the walking engine. The next thing I want to talk to you about are battles. So the type of combat that we chose to do in this game is called turn-based combat. And if you're not familiar with it, this is the easiest way I've figured out to explain how it works. We have just a simple 3-step cycle where step 1, players submit actions. Step 2, actions are processed by this thing called the game engine and looked at by the game rules, and then a new game state is created. And finally, step 3, the players are notified of the new game state. And that's kind of where our view layer comes in. We just repeat these 3 simple steps until we have a winner declared in the new game state. If this was very wordy and long-winded, I have a really easy way to demonstrate it for you, and that is using the original handheld game, rock, paper, scissors. So let's say that you and I are going to play rock, paper, scissors together. We start with 0 points each, right? Step 1, we submit our actions. We have 3 to choose from: rock, paper, and scissors. Let's say that you choose paper and I choose rock. Step 2, we submit our actions to the game state. Remember, you chose paper and I chose rock. The game rules say, all right, paper beats rock, so now you have 1 point and I still have 0 points. Step 3, we're notified of the changes. In paper, rock, scissors, it's just like your facial expressions or whatever, like, oh man. But anyway, then we just repeat those 3 steps until someone has acquired the amount of points you need to win. So how does this apply to a video game? Well, imagine we have 2 players in application state. We'll say player 1, player 2, and we can represent an HP value, which stands for health points, using these life bars. And these would be rendered with React, taking in that value of HP. So player 1 starts with HP of 100, player 2 starts with HP of 90. We'll submit actions. So let's say player 1 submits an action A that does 30 damage, but it's only 80% accurate, while player 2 submits action B that does 20 damage, so less, but it's 99% accurate, so it's way safer that it's going to hit. We submit this. Step 2, we submit to our game rules. They take in the actions and figure out what the game state is now, and here it is. Our React components are happy. We received our new game state, where player 1 now has 80, but player 2 still has 90 HP. This, like I said, this is great for our React components because they're just reading from state, so they were able to update. But there's a mystery here for the human player, and that's how do we get to this new game state? Like, what actually happened? So what we need is something human readable, that the game engine doesn't just return the new state, it also needs to give us what I call a rollout, which is like the step-by-step human readable instructions on how we got to the latest game state. So here it's just lines of text. Player A used action A, but it missed, so that's why the HP didn't change, while player B used action B and it did damage. If you remember from the demo I just showed you, our rollout was at the bottom of the screen here. And by having the player acknowledge each line of text, it kind of tells a story. It took me a really long time to wrap my head around this whole turn-based battle thing. It took me a few tries. This is what my first try looked like. Harry Potter versus Lord Voldemort, this epic battle between wizards. This was my first time using Redux, and it's where I really fell in love with Redux. But like your first time trying anything, it got a little gross, the code got messy, and I decided I needed to try again and utilize all the things I learned from the first time. So the second time looked like this. The TV show Friends, Joey, Chandler, and Ross, completely unstyled. I was just trying to get the concept down, and I purposely chose Friends because there's a lot of characters in Friends, and I wanted to code something that was flexible enough to support more than 2 combatants. This also had online support, so we could play with WebSockets against each other to actually test the game out and make sure it felt fun. Finally, we ended up at what I showed you today. And even right now, in my hotel room, I'm literally working on the next version of the battle that will be available in the next version of our game that adds more features to it. So I think the big takeaway with all the turn-based battle stuff is that it's a big system, but the big system is made up of little parts. And each part can be iterated on separately. An example of a part is the action you submit, or the notification you get back, or the rule that takes in the actions. So you can iterate on each of those parts separately without breaking anything else in the system. And that lets you play test and be set up from a technical perspective to iterate on the game rules. Because often you will get your game in front of people and they play it and they think it's too hard, or it's not challenging enough, or it's not fun. And you can iterating on those parts is the way to solve those problems. So that's a battle. There's one last area I want to show you, and that is separating application from content. This is the principle that I was talking about that helps keep the game really maintainable and easy to work on. If you've used Redux before, this is going to feel really familiar because it's how I learned how to work and think this way. But when I'm talking about application and content, an application example is what happens when a character steps on an icy spot. This is how is the game handling a situation, what happens. Does he slip, does he fall, does he spin out, or does he make some sort of fun sound effect or something? versus a content consideration is like, where are the icy spots that I could possibly step on right now? And there's a lot of benefits on keeping these two, like keeping walls between these two areas. And here are some of my favorite ones. For one, remember, we're talking about basically just keeping one global sense of application, like one single source of truth. And so if you have that, any bit of your game state is perfectly recreatable. If you imagine a screenshot of any game, theoretically, you can just pipe whatever state you need into the application, and the React views or the view layer will be reading from the application state, and that screenshot would be perfectly recreated. It helps with those bugs I was mentioning earlier, that if you have some weird edge case, you can just pipe the application state in, let the React views update, and then you're instantly right in a good spot to be debugging that problem. So this kind of means also that you get saving and loading game state for free-ish. You just need to save your game state somewhere. So you could pipe it up to RethinkDB or Firebase or whatever you want to use that's JSON friendly. The idea is that the player could play, the game state is changing, they save the game state, they come back to play later, either on the same device or a different device, and they're right back where they started. Finally, this is my favorite reason, and I have a demonstration to go along with it, is that separating application and content makes it really easy to iterate on level design, puzzles, and storytelling. So to show you that, I have a quick demo of a tool that we made for internal use. Let's see, so here we go. This lovely thing is a tool we made called Danger Studio. It's just a glorified JSON editor. And what we have is this simple, where's my mouse? Here we go. We have this simple like grid editor with some tools, kind of like The Sims style, if you've played The Sims before, where we can place objects on this map. What we're going to do here is just build out one of those map data structures that I showed you before. I've prepared an image for us to use. See, we have like an apartment building here with a bed and a dresser and a night thing over here. You know, I'll just grab this image and bring it over here. This image was designed as a 6x6 grid, so we'll tell the editor that. And just plop it in here. And see this guy kind of live updates according to all the inputs. Can you guys see this okay? Yeah, it's pretty big. So I can drag the player around where he starts, so I'll put him right here. I have a walls tool right here, which means I can mark those wall spots that we shouldn't be able to walk on. So I'll put one on the bed, on the nightstand thing, and then on the, that box. And I have a person tool. So an NPC, I can double click on any spot and do some configging here. So he's going to look like this. Remember, all we're doing here is building out JSON that's going to get piped into our game. It's just that typing out JSON by hand is fun for like 5 seconds. So I thought this tool would help out a lot. And we can set this guy's dialogue. So we'll say, hey man, are you having an awesome time at React Rally? And then we can give him another page of text to say, I got to make sure I get this right, otherwise things will crash and burn. OK, so I am too. OK, this is looking good. Awesome. All right, so I can save that. And now we're ready to preview the work that we've done. We're big fans of CodePen, the code editor in the browser. We always have the latest version of our game up on CodePen so we can send ideas back and forth to each other using like different iterations. But I'm also running that copy on localhost. So I'm going to press this localhost button, and what's going to happen is all the JSON that we've built out here is just going to get stringified, piped through a URL bar to a development copy of our game. So let's do it. All right, we get our title screen. And here's the map we made. So here we can test out the work we did. I can't step on the spots that we marked as walls, and I can talk to this guy. Yeah. I am too. Awesome. OK. So all this tool is made possible because our application has this clear separation of content and application. It lets us really build out the content of our game really quickly. And even people that aren't really technical can come in, use this tool, try out new ideas, and build out the game. So that's separating application and content. I hope the things that I've shown you today are inspiring and that you feel like the technology that you use today to build web apps can also be used to make video games. This project has been the most fun and kind of fulfilling thing that I've worked on in a really long time in the browser. So I hope that if you're interested at all, you take a stab at it. If you are interested in making games, but you're not sure how to get started and you have questions, or you are already working on a game, or you've already released a game, I would love to hear about it. So here's my contact info. My email address, drewconley@gmail.com, or my Twitter handle, or you can just come find me at the conference. We also have a website if you want to play the game that I just showed you. It's thedangercrew.com. There's a big blue play the demo button. There's also an email sign-up field if you'd like to be notified when the next version of our game is ready for you to play. So that's all I have for you today. Thank you for having me, and go out and make a game. Yeah. Thanks.